Hi everyone, today we're going to talk about setting up and solving proportions by cross-multiplying and or simplifying ratios. Perfect purple paint is made by mixing 2 cups of blue paint to 3 cups red paint. How many cups of blue paint would be needed if you have 9 cups of red paint to make perfect purple paint? So I'm going to start to model this out. So I'm going to draw 2 cups of blue paint for every 3 cups of red paint. So that's what I'm starting with. Now I know that I have 9 cups of red paint. So I'm going to draw my 9 cups. There's 3, there's 6, and here's 9. Now the question wants to know how many cups of blue paint I would need. Well, if I look at my starting ratio, for every 3 cups of red paint, I need 2 cups of blue paint. Therefore, for every 3 cups of red, I'm going to draw in 2 blue. So here I see I have another set of 3, so I can draw in 2 more blue. And here I have another set of 3 cups of red, so I'm going to draw in 2 more cups of blue. So it wants to know the total number of cups of blue paint we would need. So I'm going to count how many cups I have, and it would be 6 cups of blue paint. So if I set this up using a proportion, right, I'm comparing blue over red, and I know that I have 2 cups of blue paint and 3 cups of red paint. How many cups of blue paint would I need? And since I don't know that, I'm going to fill it in with a variable for 9 cups of red. And that's what my proportion would look like. Now I'm going to cross multiply to solve. 3 times x is 3x. 2 times 9 is 18. 3x is equal to 18, and now we have a one-step equation. So we know that in order to get the variable by itself, you must use inverse operations. Since 3x is multiplication, I'm going to divide by 3 and divide by 3, and x is equal to 6, which is exactly what we had down here when we modeled using our blocks. If I look at the next question, perfect purple paint is made by mixing 2 cups of blue paint to 3 cups of red paint. How much of each color would be needed to make a total of 10 cups of perfect purple paint? Well, if I look at this, I have 2 cups of blue paint for every 3 cups of red paint. So that means my total number of cups to make that purple paint, so now you're going to imagine that you're pouring all of these cups into a jar to give you that perfect purple paint. That means you have 5 cups in total because you had 2 cups of blue and 3 cups of red. So if you mix that all together, you have 5 cups of perfect purple paint. That is your total. We also know the total that we're looking for, which is 10 cups of perfect purple paint. So I'm going to set up my starter ratio. Now because I need to find how many cups of each color, I need to start with one at a time. So first I'm going to compare the blue cups to the total cups. So I know that I have 2 blue cups of paint for every 5 total cups, and I got that information right here. Now I'm looking for how many cups of blue paint I would need if I had 10 cups of perfect purple paint. So I know we've been talking about cross multiplying to solve. We can also look here, and this is called scale factor. I know that 5 times 2 would give me 10. So 2 times 2, because whatever I do to the denominator, I must do to the numerator, would give me 4. So that means I need 4 cups of blue paint. Now I need to figure out how many cups of red paint I would need. So I'm going to set up a second proportion and compare red over the total. So now again, going back to what I had here, I have 3 cups of red out of a total of 5 cups. How many cups of red would I need out of 10 cups? So now we could use the other method of cross multiplying. 5 times x is 5x. 3 times 10 is equal to 30. I'm going to divide by 5 to get x by itself, and x is equal to 6. So I would need 6 cups of red. And if I wanted to check this, right, I know that 4 plus 6 gives me a total of 10 cups, which is exactly what I was looking for in the problem. So I would need 4 cups of blue and 6 cups of red. Using what you know about ratios and proportionality, solve for the missing variable. So now again, we're going to cross multiply here, right? So we have 6 times 9, which is 54, is equal to 27x. And now you have a one-step equation. So we need to isolate the variable. I'm going to divide both sides by 27. And x is equal to 2. Now if you want to check your answer, you can take 2 and plug it in for the variable. So 2 over 6 is equal to 9 over 27. Now to check it, you can cross multiply. 6 times 9 is 54. 27 times 2 is 54. And because they're equal, you know you have the right answer. If I move on to this next one, 39 times w is 39w. 13 times 12 is equal to 156. I have that one-step equation, so I divide by 39. And 156 divided by 39 would give you w is equal to 4. Looking at this next one, again, we need to solve for the variable. So 10 times d is 10d. 9 times 6.4 is equal to 57.6. Divide by 10. And d is equal to 5.76. And that would be my answer for this one. Okay, looking at another example, again we need to solve for k. So 1.8 times 7.2 is equal to 12.96. 2.4 times k is equal to 2.4k. I divide both sides by 2.4, and I get k is equal to 5.4. Now again, to check any of these, you can just go back and substitute your answer in for the variable, and when you cross multiply, you should be getting the same cross product just like we did up here when we checked our answer. You buy 4 t-shirts for $32. Write a proportion that gives the cost C of buying 9 t-shirts. So I'm going to set up that starter ratio. I'm comparing t-shirts to dollars. And now I'm going to start filling it in. So I have 4 t-shirts, which are $32. And now it's asking the cost C of buying 9 t-shirts. So 9 would go in the numerator with the t-shirts. The cost we do not know, and it is telling us what variable to use. So now I'm going to cross multiply 4 times C is equal to 4C. 32 times 9 is equal to 288. Divide by 4. And C is equal to 72. Now again, if we want to check our answer, 4 over 32 is equal to 9 over, and I'm going to replace C with 72. 32 times 9 is 288, and 72 times 4 is 288. And since they're equal, we know that our answer is correct.